So we started off our research about 15, 16 years ago in the University of Manchester, and we were really interested in the fundamental physics in behind how molecules self-assemble.
So actually the first work we did was using some proteins, but then we were looking at materials we could control. That's when we started to look at small peptides. So these small peptides, the sequences are inspired from proteins which are in nature that do self-assemble.
So being inspired by nature helps us create materials that are not only functional, they're structurally reproducible, so that really helps reduce batch-to-batch variability of any materials that we produce, and that allows researchers to then use them to make products in a confident way. Manchester BIOGEL has a family of Peptigel products. That's important because every cell needs a different microenvironment to really thrive and grow. That can be different functionality, it can be different mechanical properties.
There's a very, very strong drive to go from 2D, which is most of the cell culture is done in 2D at the moment, to a 3D environment, which is the natural environment of cells. So there is a lot of push and drive to try to find synthetic materials which allow you to do these 3D materials for cell cultures.
Our materials have already been tried in mice, in rats, in sheep and in pigs, and they are non-immunogenic and there's no toxicity effects. Everything is degraded and passed out through the urine. There's no accumulation in the body.
So at the moment we have a family of 5 hydrogel that these are the ones which end up being the most used by our collaborators, and they have all slightly different property depending on what the cells requires.
Our hydrogels are easy to use and they're also supplied ready to use. These systems are very versatile. They are injectable, sprayable and can be used in patch technologies. These materials are optically transparent. That's important because you can use them and view them in the optical and confocal microscope with no issues. They are fully compatible with most staining kits. These hydrogels have been optimally designed for use as 3D cell scaffolds, for 3D bioprinting, for drug delivery and incorporation within medical devices. I'm so excited that we are developing commercial materials that are actually going to be used for real applications to help people and improve people's quality of life. To think back 16 years ago when we made that first peptide in our lab in Manchester University to where we are now, it's really a remarkable transition.